Okay, so I've taken my video, I have some data, now it's time to talk through the analysis process. For the analysis, we're going to be doing something called linearization. And to start, I'm going to take a picture of, I'm going to go ahead and copy in my times into an Excel document. And so I did that, I clicked the top part, the top box with time, I held down my left key and I dragged all the way down to the bottom box with time. And I'm going to go ahead and put that in column A in this Excel document that I have open. I'm going to go ahead and do the same with my Y position. So remember, I don't care about X, right? X is not important. But I care a lot about Y. So I'll go ahead and put that in my second box. And when I graph that on Excel, I should see the same thing I saw on Longer Pro. So I'm going to insert a scatter plot, which is this guy up here. And here's what we see. And you can pretty clearly see this is not a straight line, right? We've got a little bit of a curve here. You can also see that some of my data points are not that good, right? So you can see, right, this guy is okay, but this guy is not great, and neither of these is all that good. I also took 2 points before the thing fell. So I probably don't need both of them. So I'm going to go ahead, I'm going to clear off these two, and I'm going to go ahead and clear out my last point as well. And if you have any other, if you have any extreme outliers in your data, you also probably want to go ahead and get rid of those. Often, it'll be your first and your last point. Okay, so I am sure you guys are used to putting in a line of best fit. So, we've got our title for our graph. We're going to go ahead and make that our position versus time, since I know that's what we are graphing. You all know how to add axis titles. So on the bottom, we're going to make our axis is titled time, and we're measuring our time in seconds. And our y-axis measures our position in meters. So y'all have put in lines of best fit before, right? Gone in, you hit trend line, and then you go in and you go to more options and you test out the trend lines until one of those lines works. So the issue with that is that there's actually some problems with that, in that we need to figure out whether our trend line is actually right. So we can't just put in, the exponential trend line, or the linear, or the logarithmic trend line, or the polynomial trend line, and just pick the one that looks best. We need the one that is actually correct. And what that depends on is my data. So you can see this polynomial trend line looks really nice, but I don't know for a fact that that's right. Although if you look at your kinematics equations, you probably know it is. So this brings us back to our equations here, our pre-lab. So when we simplify this equation, s equals ut plus 1/2 at squared, what we get is that s is proportional to t squared. Or a little more generally, our position, our displacement, whatever you want to call it, is equal to 1/2 times our acceleration times our time squared. So what this means is that if I graph position versus time squared, I should get a straight line. So let's go ahead and test that out. So here I'm going to put in some labels. We've got time, we've got position. Let's do time squared and position again. So to do that, I am going to go ahead and I'm going to click the equal sign. And then I'm going to click into the box with my first time. And I'm going to hit my squared button. So let's do that. And again, I am going to say that this box is equal to this one, and go ahead and do this. Also, you can see that this decided to add this random data point here. I want to get rid of that. And I can do that by going in and just changing my series. So instead of A1, I'm going to skip that. We're not going to worry about it right now. Sorry about that, guys. So I'm going to go ahead and I'm going to graph this data now. So I'm going to go to Insert, Charts, Scatter. And you can see this is much more linear, right? In fact, here is my position versus time squared. And if I add in a trend line here, you can see that linear trend line actually fits pretty decently. And I can even go into the more options for my trend line, and I can add its, I can display my equation on the chart. I'm going to move this around so I can do that. Now, one thing I will caution you on here is you can see my data, not that great. That is on me. You're going to want to take some better data than this. Because otherwise you're going to wind up like I have here with not a great linearized line. Now, I know that this is linear because I know that this is directly proportional to, that my position is proportional to t squared. I know that from the physics. So here's where our theory affects our interpretation and our analysis of our data. So what I'm going to want to do is add in my axis titles with, again, the correct information. So my y-axis, my x-axis, now has my time squared. My y-axis now has my position. And I have a trend line, and what I want in my trend line is to put in all of my initial information. So y, instead of y, I want to put s, right, because that's my displacement. And instead of x, I want to put t squared, because that's what that variable actually is, right? So I want to replace y and x with what my y and x axis actually has. And then looking at that slope, I can figure out from here what my acceleration due to gravity is. And there you have it, folks. You now know how to linearize data. Now, I do want to mention in the analysis, you are asked to use the slope of your linearized graph to determine the acceleration due to gravity. What I want you to remember is that for your linearized graph, s is y for your line of best fit, and t is x. So you're going to figure out how that fits in. I'm not going to tell you any more than that because that is on you. So with that, I am going to go ahead and sign off. I'm going to give you the best of luck though, and happy solving. Bye guys.